let's keep on going here. Okay, so I want to talk now about processes. Ladies and gentlemen, I've already given you a glimpse of using process information when I just checked, is this process running? Is bash still running when I'm TCSH? What did I type? What did I type to find out, is bash still running? I typed awk? Oh, yeah, I typed AUX originally, that's true. What was the command name? That was the option for it. PS, yeah. So I can do PS here, and ladies and gentlemen, these shows various things that I'm running. So I can exit from there. Oops, hey, get me out of here. And I can do PS, and I can see now I'm running CSH. That looks like that was my original shell. CSH. And I'm running a bash with, I'm running a TCSH within that. I can exit back to bash. I can do a PS now. Now I'm just running, well, I'm running PS, sure, but I'm also running CS and bash atop, and I could leave that, and now I'm back to just CSH and bash. So these are processes. These are things that are running at the same time. They are independent, we call them threads of computation. The image here is they're sort of hanging in parallel, and execution is kind of flowing along them at the same time. Things can be going on at the same time. You could be running an editor at the same time. You're printing something at the same time. You're figuring out how much space you're using on disk by going through each file at the same time. You're going and receiving data over a network. And in general, we have many ways of doing that within computer systems. We could have different computers running these things, but within a computer, the basic unit of operation is something called a process. Okay? And a process, for your intents and purposes now, you'll find more advanced coverage of this in other classes, but for your intents and purposes now, it's a sort of separate thread of execution, separate sort of mode of execution that is running fairly independently of the other. So it can be communicating back and forth. For example, we may have, well, what have we seen in cases already in this class where different processes need to communicate information in a very structured way, handing it off to each other like a bucket brigade? Sorry? Pipes, yeah. Yeah, so for example, we had some pipes going on when we, for example, were doing that, cat piping out to something like unique, piping out to word count. Remember that? Now, these things are actually going on, and it says, as I typed, they're going on at the same time. Unfortunately, that's in a way where you can't really see it, so I'll just confine it to two of them so it can be immediately obvious. That's a unique one, but it doesn't print anything further there. I could say cat, and it's just printing out each successive one that's unique. If I want to see actually what's running there, I can do something called suspend the process. Okay? I can press Control Z, and you notice it says suspended. That doesn't mean it's gone. It's just temporarily it's stopped executing. And I can do, what could I do to see which processes are running right now? PS. And I can see here's a cat and here's a unique. And they're separate processes. One is process ID 6190. Another is a process ID 6191. They're created by the same basic so-called terminal number. But one is 6190, 6191. So here, ladies and gentlemen, we have a cat providing information to a unique, and both are running on separate so-called processes. They're both doing jobs at the same time. Now, in general, I might have processes that are running for long periods of time, like an editor that I stay in day after day, or something that's receiving file things from the network and putting them onto your disk. Or you might use commands like wget and curl to, be retrieving retrieving information from online sites and putting it, doing a spider that crawls various online sites, gathering information or what have you. And these things can be running for long periods of time. After all, it's a pretty big web out there. And those can be running at the same time you're doing other things. So in general, you're going to have many processes running. And ladies and gentlemen, on a given machine, there'll often be many types of processes running. So if I do PS and I want to do options with it, so I want to use an option to let us see processes from all sorts of users. I could do a PS minus A, and I could see, oh, these are various people doing things on this machine. I could ask to see user information associated with them here, and I could see sort of, what's going on, what are people doing, and I could do AUX, and I could see extra information associated with this. How much CPU, how much memory are they using, etc. Okay. So in short, we can get access to sort of what's going on at the process level with a variety of tools. PS is one of our main tools. Another one is TOP, and TOP is a little bit of more sort of visually appealing tool. Here we see various users, and for different users, for example, the one at the top, there's this person called JSE313, and they're running a certain application over their NX agent, which is just maxing out the CPU right now. It's not using too much memory, it's using 0.1%. It's been running for a long time, 2987 minutes and so many seconds. And you can see the process ID associated with that. Okay? There's also some global information up there at the top. Now, this is information which I might be interested in on an ongoing basis. If I just want to leave it, I can press Q. If I want to suspend it and come back to it, what can I press? Control Z. And you'll notice it says suspended signal. Actually, if I say jobs, I can see, oh, there's two things that are suspended. Two things that are running in the background. Cat, and this cat unique process, and TOP. Now, if I want to turn them back into so-called foreground processes, so they're actually doing things, I could press FG2, and there we are. They were freeze-dried away, just waiting to be reactivated, but add water. I added the water. I said FG, this number as given by jobs. Let me show that again. I do jobs. I look at the number here on the right, and I could say FG2, and here we go. So it just continues on. Alternatively, I could do FG1, and what's going to start running again? Ladies and gentlemen? Yeah, oops. Let me try that again. Excuse me. Okay, so I do jobs, and let's try that again. So it turns out, you would think that, but there's actually a different syntax required. So there we go. So it's actually %1 that's actually required, %2. So here, this % sign indicates the job number, so 1, job 2. So here, I'm back to this thing. So what would you expect to happen if I type dog and then dog again? Nothing. I'm back in this whole operation. So I can suspend it again, and again I can see various jobs running here through suspension through this jobs command. Okay, so what are we seeing here? Processes. These processes exist as more or less independent threads of processes. They can communicate, but they're operating fairly independently of one another. Now, a single program might invoke several processes to get the job done, and a single process may actually, in some cases, run multiple specific sort of programs. So we're dealing with some simplifications here. But generally speaking, we're going to have processes that start up other processes. where have we seen that already? Where did we, in this lecture, see a case where one process started another? Sorry? Okay. Cat and unique were more like siblings in the sense that one is providing information to another. So it was providing as a producer-consumer relationship. Cat produces, unique consumes. Where do we have a case where one thing actually created another? Maybe because we told it to do so. Yeah. So we had TCSH, for example, starting bash, and even before TCSH, we had my CSH starting bash, right? I could type things and I could ask for bash. So this is a case where we have sort of a hierarchy of sorts going on. One thing is, you know, bash, CSH created this. We could say it was the parent of bash. CSH begat bash, and bat begat, you know, another bash, or what have you. So here we have this sort of parent-sibling model. So each process has a unique parent, and parents can have multiple children potentially. So let's go take a look at this as we see it on the command line. So ladies and gentlemen, here I am. I'm gonna invoke bash here, and I'm gonna say PS. What am I running? Well, remember I'm running CSH. Why does it still say cat and unique? They're still there. They're suspended. And in fact, if I did PSAUX, I could kind of go look at the status of each job. I don't have to do it for all users, for example. I could just do PSAX here, PSX, and I could see something about the status here. So, for example, here I could see that cat and unique are associated with a status where they're actually currently suspended. But here, I could moreover go take a look at the structure, the structure in a more graphical way. Specifically, what I could do is I could do this command called PS tree. Okay, so if we go to PS tree, what we can see is there's actually a hierarchical structure shown. Okay, and PS tree. If I want to find out various options for PS tree, I could do man PS. Oh, not tree. PS tree here. And you'll notice here that we have this one H. So highlight the current process and its ancestors, okay? So that would allow me, PS tree minus H. That would allow me to sort of see, for this particular one, I'm within bash, and that's occurring within CSH. And that's occurring within a set of other processes that are handling my what? Yeah, secure shell connection. This D actually means daemon here, or daemon, D-A-E-M-O-N, which is sort of a process that's constantly running in this machine in this case. It's just constantly waiting there in case someone connects with SSH, it's ready to serve them. It's like a taxi cab driver waiting at the airport, just waiting for someone to get in. And we call that sort of process a sort of service. Called service, and it's associated with a particular name in Unix by default, and this carries over to some other operating systems of a daemon. The idea is it's sort of ready to serve when called upon, and it's just constantly running in the background. In this case, that's kind of handled my connection, and then I started CSH, and then I started bash, and then I ran a PS tree. And you'll notice I have these other things here under bash. Why is that? Yeah, so these are siblings here. So I have a cat, and that's in a pipe with unique, but they're also on running top here. Okay, so those are siblings. Cat didn't create unique; it's a sibling with it. It just hands off information to it. It's a peer. That's a P-E-R. So they're peers. They're sort of equals. Okay. in the scheme of things, whereas bash created them. And ladies and gentlemen, if I left bash, so I'm going to exit bash here, and if I do now a ps tree minus h, here I am in ps tree, they're actually still within CSH, okay? So if I say jobs, you'll notice that they're actually still running here. Top is still running, and I can actually still reconstitute them from that original shell. So let's take a look at this in a little bit more detail. If I went into bash, and I went and I, for example, did if I tried to sort user dict, user Linux, forgive me, I've forgotten the exact folder it's in Linux, so let me just find a longer command here. If I want to stop, for example, so if I want to do a word count on 5k ccsh var, okay, and I want to stop that here. Oh, it's too fast. I'll sort it, okay, and then I will stop it, okay. So I've started this, so if I do a ps tree minus h, here we have the sort going on within bash, and if I now exit from there, it's actually going to say there's stop jobs, okay. So how if I want to kill those jobs? What if I don't care about them anymore? First of all, I can see their names, and I could say, for example, kill one, okay. And you'll notice it kills it. It says stopped and then terminated, okay. Another thing that I could do here would be to, instead of doing kill this %1, meaning job number one thing I could do would be to use a PS. So I'm going to go, for example, here, start this up, stop it, and another way to do this would be to do a PS. I can see, for example, that there's a sort going on, and I could say kill process ID 7116. Now it turns out that to accomplish a kill, it sends messages to say basically, hey, handle this message. And the most severe message is -9. That's gonna say, you know, you die immediately. Don't clean up yourself. Don't worry about things. You're out of here. So a kill -9 sent here to a process number 7116 sort will kill it. Now I don't see that immediately. You notice I pressed this enter and I didn't see anything, but I pressed enter again and it says killed. And what is this thing here? That was the sort that I had suspended. That was the sort that was running. And now, having killed that, if I go up and I look and I use my PS tree to kind of see where am I now, I should be able to exit out and do a PS tree here. And I'm back to this place where there's so that's no longer blocking me. Okay, a couple more commands here. There's commands to find out who else is on your system. This traditionally has been important in the context of multi-user systems. So the W command will tell you who's on it, logged in right now, and what are they doing. Alternatively, you can use the who command, which provides different information, including where they're coming from, for example. For example, these are some people coming in from Shaw cable connection. Others are connecting from particular machines. You notice I'm connecting from this machine here, which is my local machine. Okay, so there's W and who to find who's online. We've talked about exit. I also mentioned Control D. Where did we see Control D before? Yeah, end of file. So if I do cat and I want to, cat something to a file, foobar, and I'm done with that. I can press Control D, and that will complete that file. By contrast, if I want to suspend cat, I press Control what? Z. Exactly. Exactly. Okay. So, ladies and gentlemen, if you're running commands on here, like ls, what happens is once this gets unpacked, once this home gets expanded, once these things get expanded, all that gets done before this process starts up. The aliases get expanded. At that point, it's ready to be created. And what will happen is there'll be a new process called ls, in this case. It's an ls process. And it will be running, and it will have certain so-called arguments as provided here. So this might be several files that will be provided to it as arguments that it knows about. These are particular files. It doesn't actually see this star. It doesn't see this star. It doesn't see this home. All that gets given to it is all handled before it receives it. So if you write a command, and you will be writing programs that will take these sort of things. By the time your code gets it, all these things are done for free. You don't actually have to do anything to handle these things. It's all handled by the shell. Okay? So these processes that we've seen with PS, or processes seen with top, or with PS tree, those are processes for which the work has already been done. These things have been created, and they don't even necessarily know, we won't know, that they're in, for example, a relationship associated with typing. All they know is they take things from the standard input and they pass it to the standard output, and the system will take care of making sure that gets to the next process. So cat does its job, and the system as a whole takes care of passing the output from that to the input to unique. Okay? Does that make sense? Okay. So let's see a couple of things here. So we've seen kill to kill processes, and we've seen kill -9 to totally terminate a process. I've tried to distinguish between a foreground process here, where we have things that are in control of the keyboard. So we do jobs, for example, there's this process, we could do foreground, and we can type things in. This is control of the keyboard, it's listening to my keyboard, versus a so-called background process, a process that's running, it's not suspended, it's running, but it doesn't actually require user interaction. It's going on at the same time as whatever we're doing with the keyboard, but it's running in the background. So some processes are running in the foreground, some processes in the background. So for example, maybe I want to be doing this work in front of you while running DU in the background. Okay? Now a naive way to do that would be to start up DU and tell it to run in the background. I can do that in the shell by giving it this ampersand after it, and it'll be running in the background, and I can be typing things. You can't tell, but I'm typing things. The problem is it's really distracting. How if I wanted that to be going on in the background while I'm doing other things? It doesn't clog the screen. What would I do? Okay, so here's this ampersand. It's running in the background, but suppose I want its output to go somewhere else. Yeah, so tell me what to type. Suppose I want its output to go to sort of, my disk use. I could do this, right? My disk use. And now it's running in the background. You'll notice I'm doing various things. I'm running my favorite process, and now it's just finished. You see that? So, in short, ladies and gentlemen, this thing is actually running for a while. Excuse me. So you notice it expanded that. So, that's an interesting It's an interesting thing. Okay, it's proving truculent about that. So I'll put it to my disk use 2 here. And we'll have it run in the background. It's actually still running here. If I do a PS, I'll find that DU is running. It's a background process. It's not suspended. It's not running in the foreground. It's not handling my input. Instead, it's actually running as a background process. Okay? So we'll try that again. It's because I put that ampersand here that it tells it to start it as a background process. Okay? So if I do this again, and I do, PS, AX or something like that. Well, I should have done it quicker there. So I'll say PS. Oop, yeah, it's already done. It's too quick. Here, ladies and gentlemen, as it's running, it's actually running completely in the background. It's running as a background process. Some processes like that might run for a very long time. They might take their input from the network. They might take their input from a tape drive that's only reading things out very slowly. In this case, it was doing a job looking on the disk, but it was able to do it reasonably fast, but it ran in the background for a while. So we have, ladies and gentlemen, 3 types of processes to deal with here. We have foreground processes. We have background processes. And we have processes which are suspended. Okay? So a lot of processes in this machine are going to be background processes, and I can start one explicitly by giving a command and typing what after it? The ampersand. Right. And that will actually start it up in the background. It will still run. It's just that it won't have keyboard associated with it. A foreground process has control over my keyboard. It handles my keyboard. And a suspended process is just freeze strong. It's just waiting to be reconstituted at a later time. It's not actually operating. It's frozen. Okay? This is a frozen process. So be aware that when it comes to using Linux systems, that there's a lot of things going on beneath the hood here. There's a lot of things going on which are not foreground processes. People are not actually actively doing them. They're either suspended or they're in the background. Okay? Okay, we're reaching the final minutes here. Just a couple of more things. First of all, suspended processes are they're not running. They are using memory still, so generally you don't want to have a lot of them around. And we use the term job to mean a suspended or a background process. So that's kind of a catch-all job for these sort of processes. We call them jobs. Okay, and that's why when we type jobs, it will show both types of processes. Okay. Well, we've seen this. I can turn a process that is suspended or a background process into a foreground process by typing FG and the number of the jobs. So job 1, job 2, for example, etc. So if I get a list of jobs, I can convert ones from background to foreground or from suspended to foreground by using the FG command. Okay? So that turns something that was put aside into something that's front and center now. Okay? I can also change the priority for things. I think I'll leave that for now. So in our final 2 or so minutes here, 2 or 3 minutes, any questions related to this? We've seen it fairly quickly. Questions? So what have we seen? We've seen processes. We've had a reminder that processes get started up, for example, from a command line, after doing a lot of work that the shell takes care of for you. In other words, it takes care of expanding path names, it takes care of expanding variables, it takes care of expanding wildcards, it takes care of aliases, all that sort of stuff gets done. Then the process gets created. It gets provided with all the information about what options are given to it. It gets provided with information about what files to operate on. It gets set up to have standard input and standard output and standard error out of itself. So this is stood in, this is stood out, and this is stood error, say. And it just has to do its job. It doesn't need to know if it's in a pipe. It doesn't need to know if it's putting things in a file for read action. It just does its job, put things up as stood out, as stood error. And it's running in a way where all the information was given to it by the shell. We've seen that these types of processes can be associated with different users. For example, they can be run in the foreground where they're actually using the ongoing input from the user. They can be run in the background where they're running actively, a key thing, they're running actively, they're getting work done, but they are behind the scenes getting that work done. They're not blocking the user from getting work done themselves. They are doing their job, it's just they're doing it, without holding you up. And then finally, suspended processes, which are processes which you've requested, hey, suspend this, maybe I'll come back to it later when I have time or I have interest. And an example of that would have been that top process, where we had started top and we suspend it, and we can very easily, for example, go back to it and start running it again if we see fit to do so. So these are the three types of processes that you want to keep in mind, and we call the latter two types of processes jobs, and you can list them with the jobs command. Okay? So that information should be helpful for this lab, possibly for next lab. Okay. And please provide feedback so I can know what things need further coverage. Thanks a lot. Thank you. Thanks. Thank you. Great. Thanks a lot. Thank you.
So I did the lab last week. I handed it in actually on Tuesday.